Hi, this is Math 2520, and this video is over chapter 10.8. Now, we're going to mainly look at review. We're reviewing all the different conversion tests because there's a lot of them, and kind of go through each one with conditions of convergence and divergence, and then the kind of comments for these. We'll do a couple, at least one example for each. So, I mean, there's so many tests, how do we choose? And so it's best, this is when you have to use some recognition with things, recognition with numbers, recognition with functions, and just what things look like, to gain some kind of intuition to how you go about this. It's not the easiest. At the very end, there is a flow chart, but even the flow chart is very complex. So first, check for divergence using the test for divergence to determine if the sequence we have and if it sums up whether or not it has a limit for the sequence. So S sub n. So conditions for convergence: limit as a sub n as n goes to infinity equals 0. This is only possible convergence, doesn't mean it will converge. Limit as n goes to infinity of a sub n does not equal 0, series is divergent. Okay, so doing this test, you can determine if a series is divergent, so you don't even have to worry about looking for convergence. But it cannot prove convergence either. So summation from 1 to infinity of e to the n over e to the n plus 5. We're going to look at the limit as n goes to infinity of e to the n over e to the n plus 5. The limit as n goes to infinity of e to the n that goes to infinity. And the limit as n goes to infinity of e to the n plus 5 also goes to infinity. And so this series does not have a limit that goes to 0. The series is divergent. And we look at n over e to the n. The limit of n goes to infinity over n over e to the n. Both is going to infinity. This time we can take L'Hopital's rule. And we'll get 1 over e to the n. Or we can say as n e to the n. Bottom's going to infinity. Top is just 1, so this goes to 0. We have possible convergence. Up top here, if we took L'Hopital's rule, we would have limit as n goes to infinity of n e to the n over n e to the n, which is just going to go to 1 basically. So it's not going to go to 0. Alright, 2 to the n over e to the n. So we're going to look at the limit as n goes to infinity. 2 to the n over e to the n, which is 2 over e to the n. 2 over e is less than 1. Alright, so limit as n goes to infinity of 2 over e to the n will go to 0. Think of it as e goes faster to infinity than 2. And 2 to the n. Alright, so we have possible convergence. And then summation of 3n squared plus 1 over n squared minus 1 to the n. Do the limit as n goes to infinity of 3n squared plus 1 over n squared minus 1. And we can divide everything by n squared. We get 3 plus 1 over n squared, 1 minus 1 over n squared. As n goes to infinity, this goes to 3. So this limit then is now 3 to the n, which is going to go to infinity. So series diverges. Alright, so alternating series tests. This is one you can look at when you have negative signs involved. So the form n equals 1 to infinity of negative 1 to the n minus 1 bn, or n equals 1 to infinity of negative 1 to the n bn. Here an plus 1 is less than a sub n, and the limit as n goes to infinity of a sub n equals 0. Then you have convergence. And then condition for divergence is either of these is true, false or untrue. If this one had the remainder error r sub n is less than or equal to a sub n plus 1 as well. So reminder on that one. So we look at negative 7 n plus 1 over n plus 100,000 less than or equal to, I forgot to add 1 here because it's n plus 1. So that 1 goes into that 10,000. 10,001. Next is negative 7 to the n over n plus 1,000. Okay. So negative 7 to the n goes to infinity much faster than n plus 1,000. What we can do is we can look at this as negative 7 n plus 1 is greater than or equal to negative 7 over n at the bottom, n plus 1001 over n plus 1000. And this ends up being just a negative 7 greater than or equal to n plus 1 over 10,001 over n plus 10,000. This side is always positive. And so -7 can't be greater. Okay, which means this is untrue. So it's really this side, which means that this series is divergent. Next one, -1 to the n, e to the n over e to the n minus 3. Okay. We'll look at this as b sub n is e to the n over e to the n minus 3. And b sub n is positive when n is large. So e to the n over e to the n minus 3 greater than or equal to e to the n plus 1 over e to the n plus 1 minus 3, which we can look at that as e to the n e to n minus 3. Alright, so that divides out. Oh, no, I'm sorry. That is not the right thing to do there at all. I got thinking that -3 was an exponent. I gotta multiply that over. So we'll have e to the n, e to the n minus 3, greater than or equal to e to the n, e to the n minus 3. Let's see what I gotta do here. I just want to make sure I didn't make any mistake here. Okay, this can become e to the n plus 1, e to the n minus 3. And then when I divide over e to the n, I get e to the n minus 3. Then distribute. Alright, so now we have two numbers that we can compare. So this is the same as this. And here we're subtracting 3. And here we're subtracting 3e. Okay, so we're subtracting a larger value here. So this statement, this means this is smaller. This whole thing is smaller. And so this statement is true. So sequence is decreasing. Okay. So now we go back up here, limit as n goes to infinity of b sub n, which is limit as n goes to infinity of e to the n over e to the n minus 3. this is going to go to 1. And so this series is divergent. Okay. So geometric series now. It's going to be of the form n equals 1 to infinity of a r n minus 1, which is a plus ar plus ar squared. So here r is less than 1 for convergence, and r is greater than or equal to 1, you have divergence. Absolute value both of these cases. And then the limit of the series is a over 1 minus r. So you can keep that in mind as well. Alright, so sometimes these take some adjusting in order to see. So this is going to be 1 over 2 e to the 2n, e to the third, which can be written as 1 over e squared, e to the third, all to the n. I'm sorry, not all to the n. That third is not to the n. That is to the n. And then e to the third. And we can write this as 1 over e to the third (1 over e squared n minus 1 (1 over e squared). So I'm pulling an e squared out of there, so it subtracts by 1. And so we have summation n equals 1 to infinity of 1 over e to the fifth 1 over e squared n minus 1. So here a is 1 over e to the fifth, r is 1 over e squared, which is less than 0, oh, less than 1. So series converges. And then the limit is 1 over e to the fifth, 1 minus 1 over e squared. And that comes out, if you put that in a calculator, to about 0.0078. Some of these don't take as much work to get them into a right form. Here we'll separate this into 2 of these. So 6 over 8 to the n plus 7 over 8 to the n. Both of these have r less than 1, so series converges. Okay, so here a is going to be equal to 6/8. I'm sorry, no, r is going to be equal to 6/8. A is equal to 1. Here r is equal to 7/8. A is equal to 1. So your limit is 1 over 1 minus 6/8 plus 1 over 1 minus 7/8, which is going to be 1 over 2/8 plus 1 over 1/8. 1 over 2/8 is a over 2 plus a over 1, which is going to be 4 plus 8, which is 12. Now don't confuse the geometric series with the p series. With the p series has a different form, but I can see why it can be confusing. N equals 1 to infinity of 1 over n to the p. So it still has an exponent, but that exponent is a number, and the n is actually not the exponent. So here p is greater than 1, it's convergence. P is less than 1 or equal to, it's divergent. We use this a lot for comparison tests. So here, if we adjust this, we get 1 over 5 to the third times 1 over n to the third. And so here, oh, let me write this a little different so it matches the form. N to the third. Okay. Here, p equals 3, which is greater than 1. So series converges. Here we can rewrite this as 1 over n to the 7/4. P equals 7/4, which is greater than 1. So again, series converges. The that's the p-test, the direct comparison test. I feel like I skipped something. No, I guess I didn't. Okay. So here we'll look at a series and it looks similar to either a geometric or a p-series, but it's a little bit more complicated. Right, so the form of the series is similar to geometric or p-series, but more complex. So in this case, a sub n is less than or equal to b sub n, and a sub n converges, then b sub n converges. Or a sub n is greater than or equal to or greater than b sub n, and a sub n is divergent. And b sub n is divergent. So we have to decide on a series for b sub n to compare it to, and then one that we can actually solve as well. And so we have to know whether or not, and then we have to be able to tell whether or not b sub n is greater than or less than a sub n on top of that. And then also if a sub n has some negative values, you can always compare it to the absolute value of a sub n. Right, so here, I want to adjust this. N to the third over n plus 4 over n. And so this could be written as n squared plus 4 over n. And as n goes to infinity, this goes to 0. So it becomes just n squared. And we can write this as 1 over n to the negative 2. So this is a p series, for p equaling negative 2. So p is less than or equal to 1, so n squared diverges. Next one, we're going to look at this as n to the third over n to the 8th, which is roughly 1 over n to the 5th, which is a p series, with p equaling -5. I'm sorry, p equaling 5. And so that's greater than 1. So series converges. So we'll compare this to n to the third over n to the 4th plus 1 squared. And 1 over n to the 5th. Okay. If we think about this, this is this number here is smaller. Well, this number here, this the denominator itself is smaller than n to the 5th. Which means, you know, when you cancel out the numerator with that, we're looking at something smaller than n squared. Right? And so because the denominator is smaller there, it's going to be larger. So this one's larger than 1 over n to the 5th. And so if this 1 over n to the 5th converges, then n cubed over n to the 4th plus 1 squared, which is greater than it, has to converge. Now, similar to the comparison test is the limit comparison test. Okay, so when something looks like you can use a comparison test, but seems kind of tough, or justifying it is tough, then we look at this limit comparison test. Here, the limit of n going to infinity of a sub n over b sub n equals c, where c is greater than or equal to 0. We look for see if both series converge, or if both series diverge. So we're going to compare this one, this is n squared, to n squared over n to the 6th, which is roughly 1 over n to the 4th. So we're comparing 1 over n to the 4th to this. 1 over n to the 4th is a p series, where p equals 4, which is greater than 1, so it converges. And since n cubed plus 4 would be greater than this, is, oh, I'm sorry, it'll be less than this. It's going to it also will converge. Right, so n squared over n to the 3rd plus 4 squared also converges. We got the integral test. So I see a function in which fn equals a sub n, and I can easily calculate the integral from k to infinity of f of x dx. Then f is continuous, positive, and decreasing. So if from k to infinity of f of x dx is convergent, and we have convergence. And if this integral is divergent, then we have divergence. Right, so natural log of n squared over n. Alright, n is much greater than natural log of n squared. So series is decreasing. This thing gets in bigger. Continuous, there will be no breaks, so it'll be continuous and always positive. Right, so limit as t goes to infinity, 3 to the t of the natural log of x over x, that top being squared, dx. We'll let u equal natural log of x, du equal 1 over x dx. So this becomes a to b of u squared du, which is going to be u cubed over 3 from a to b, which is going to be natural log of x cubed over 3 from 3 to t. And so limit as t goes to infinity, natural log of t over 3 cubed minus natural log of 3 over 3. Now this part is just a constant. This part here goes to infinity really slowly, but it will go to infinity. Right, so this whole thing goes to infinity. Right, so series is divergent. Right. So now we're going to look at the ratio test. Let's see how much I have left here. Ratio, root test, telescoping series. This is blank. Okay. Didn't expect that. And some other ones. Alright, so I'm going to stop this video. We'll make this 2 parts because I don't want to get too long. Okay, so this is part 1 of 10.8, and part 2 will start with the ratio test. Alright, I'll see you then.